So yeah, today we'll solve this problem. Okay, I already solved it. This is the problem of generate parentheses. Okay. Actually, I was seeing the optimal approach. Okay. The brute force approach I already solved, but but I was trying to I was actually I actually I was trying to make the solution optimal so that it can solve in 2 power n. Okay, so this solution is already okay. I can show you by submitting once. Okay, look. This passes all the cases, but um, yeah, yeah, this passes all the cases. But there is a problem that uh, in this function for each call. Okay, I am taking uh, two more calls. Okay, one for the one for after adding the opening bracket, and again after getting back to the after getting back to it by return. Okay, then I'm making another call with adding closing bracket with the string. Okay, so now also when the string length is 2 into n, as you can see that when n is equal to 3, each string is a length of 2 into 3, I mean 6. Okay, so we can say that the string length will be 2 into n. So when the string length is 2 into n, I am checking the string that is that string is valid or not. Okay, actually it's balanced or not. Okay, so this is the algorithm of checking the validation of the string. Hmm. Checking the validation of the string, and this executes in big of n. Now for like for 2n number of recursive calls, I am checking for each call. I'm checking the string so that it is valid or not. So it's actually taking 2 into 2 to the power n square. Asymptotically, if I say if I speak in asymptotically, then it will take big of 2 power in square time. Okay, so it's a lot more time. It's a lot more time. So that I was searching so that searching a solution so that I can solve it in 2 power n time. So yeah. Also uh, I have made the recursive state space tree of the recursive calls of previous solution. Okay, which I have made already. Also, I should say that this solution I didn't wrote it on myself. Okay, I saw the solution, and it took me 2 hours. Okay, it took me 2 hours. After that, I gave up to getting the solution. Then I go to the solution page of that in the page of Take You Forward, and I saw the algorithm. I didn't see the code. Okay, I just saw the algorithm and build and understand with my own. Okay, yeah. So this is the state space tree. Okay, I can give you the uh, diagram. Okay, so yeah, this is the state space tree. Here I got a valid string. Okay, this is a valid string, the first valid string. Okay, then another one is this. Okay, so when this state space tree is when n is equal to 3, and so that now this is another one. Okay, now it's going to be 2 power square time, and then I thought that let's make it optimal. Hmm. So that's the algorithm. I saw it from here, got it from here. Yeah, this is the algorithm. Okay, I just took it here. I don't want to see the code. I want to do it on my own. And yeah, so I started with empty string. Okay, and open which is op is equal to 0, and close cl which is equal to 0. Now, now here I am taking aim is equal to 2, right? Now OP is 0. Now OP is less than 2. Okay. Then then add uh, S S will be now S plus opening bracket. Okay. And also open OP will be plus 1. Right. Right. So then again I will make a call. Okay. 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 Now here OP is now it's 1, okay, which is less than 2, right? 2 is n, okay, 2 is n. Now again I will add opening bracket to s, okay, s plus opening bracket, okay, and again I will increase OP, okay. Now I will again recurse. Now OP is equal to 2, which is equal to 2. So what I'll do, I'll stop. I'll stop adding. Okay. So I will not add. Now close. I will check close. So I- okay. Yeah. Now I will check for close. Now close is equal to 0, which is less than OP. So I will add. I will add S S. Okay. I think I should also mention the current S. Right. Yeah. Okay, here S is empty. Okay, I just done add a opening bracket. Then S becomes here it was here is S is equal to it was only uh, right. Okay, now it becomes this. Okay, S is equal to okay. Now it will become okay as now S is equal to 2 equal to N. I mean OP. Okay, so now what I'll do what I will do I will add a closing bracket, right? And I will increase close. Okay. Now I will again recurse. Now OP is 2. Okay, that's okay. Now close is 1. So 1 is also less than 2, less than OP. So again I will add. Again I will add. Now the current state is opening bracket, closing bracket. Right. Now I will add another closing bracket to it and also CL plus 1. Right. Now Now again I will recurse. Right. Now OP is 2. CL is also 2. So which is actually equal to OP. Right. So now it will happen that s is equal to, it's becoming, okay, this, okay, becoming this. So now its length is 4, which is 2 into n, right? N is equal to 2. So then I will add it to answer dot push back s, right? And it's already valid. Hmm. Okay, then I will return. Then I will return. Okay, then okay, then I will return to the previous step. Now this is also completed. So again I will return. This one is also completed. Yeah, I've done it. Yeah, again I will go to the, yeah. Now, okay, this now now if I see that ace is now having only a single bracket. Okay, now I already executed for OP. Now it will execute for close, close, for closing bracket. Now if we see, then OP here will be OP is equal to, there will be 1, right? Which is less than 2. Also, uh, now CL is 0, and which is less than OP till now, right? So here OP is 1. Here OP was 2, right? Here OP is 1. So now, so okay, okay. Now here now uh now it will happen that S is equal to, okay, actually this thing will be there. I think, okay, let me this. I think the call will be make it from here. Yeah. Now uh S is equal to single bracket, opening bracket, then S plus, as close is 0, then a closing bracket will be added, and CL plus 1, right? So now it will become, now it will, okay, now here OP is 1. Okay, OP didn't change. Okay, OP is also, okay, in this call, okay, OP is less than 1. So again, something will happen that, okay, let me understand this. I think I am doing something wrong. Here OP becomes 1. Okay, 2. Okay, not the, okay, this one's 2. Yeah. Now in this step, it's actually yes, that OP is 1, which is less than 2, and CL is 1, which is less than 1. Okay. Now CL will for CL it will execute later. Before that, for OP it will execute. Will be increased, right? So I think okay. Let me write it. This whiteboard is a bit problematic for me because, okay. I don't want to complain, but uh, okay. Now, okay, this thing is like this. Okay, is now OP will be opening bracket. Okay, and OP plus 1, right? Now it will call. Now here OP is equal to 2, which is equal to 2. So for OP, no recursive call will be called. Recursive call will be executed. But CL is now 1, right? So CL is 1, so which is less than OP. Okay. So for that now closing bracket will be added, right? Is equal to, and okay, this thing was like this, and is closing bracket, okay, and CL will be increased, right? Now again there will be a call, right? Now is will become, right, and and length of it is equal to 2 into n, which is a base case, okay. So it will push into the answer vector, right, and then return, okay. So it will return back to the previous one, okay. Now it's already completed, okay. I have to write this one. Here OP is equal to 2, which is equal to 2, and CL is equal to 2, which is equal to OP, right? So it's already achieved the base case. No recursive call will be executed here, right? In this call, right? So then it will achieve the base case. Now it will return. Okay. Now it's also this call is also completed, so it will return to it. Okay. So now OP is 2. Now here OP is 1. Okay. So one thing will happen that here OP is 1. Here OP is 1. The CL is okay. Okay, is 1. Okay. Okay. This thing will also return. This thing is already completed. Now this. Okay. Now here OP is 1. Now OP will be okay. Now for OP the call is completed. Now there will be, why I added CL. Okay. Oh, this thing is already completed. So it will back to this, and then it will return. Okay. Okay. No. No. It will not return. It will not return. Then it will not return now. For OP, it's completed. Now it will call for CL. Okay. Now it will call for CL. Now if we see that for n is equal to 2, there will be only two combinations, parentheses, valid parentheses combinations, right? So we already got it. We already got it. We already got it. So yeah, the extra call will be executed, but those are unnecessary. So, but we can't remove them here because for n is equal to 3 or n is equal to 4, maybe it can happen that uh, we have to call those we have to execute those calls. Okay, so let me write the solution first. Okay, I will reset the platform. Okay, yeah. So I will take a vector which is called answer, an empty string. Okay, an empty string, and also okay. Now I will call the solve function is answer, and and op op and close, op open and close. Okay, this one is op and this one is close. Okay, and I will return answer. Okay, then void solve um, vector string answer op and save close. Okay, now if okay, oh, also I need to pass the I need to send the n also. I need to send n. Wait. This will be the best case. Okay. Now this is the best case that if the string length is 2 into n, okay, then I will push s to answer vector, okay, and then I'll return back to the previous call, okay. So this is the base case, and when is dot length is equal to sorry, 2 into n, okay, then answer dot push. Okay, one thing I can think that actually it will not execute this call. It will not execute this call because in this state OP is 0. In this state OP is 0. Right? From here, I was thinking, sorry, I was thinking that from here again it will be a call, but here OP is 0. So CL is not less than OP. It's actually equal to OP. So for CL, it will never execute a recursive call. Okay. As also if we think logically, then a valid parenthesis can't be start with uh, a closed bracket. Okay. There will always be a opening bracket. So it's logically it's okay. Then return. Now if OP is less than n, then call solve in s, add a opening bracket, answer OP plus 1. Okay, let me remove this space. I'm very particular about formatting, so I don't know why, but yeah. Else if CL is less than OP, then solve in S, answer OP plus 1. Right? Yeah, that's the function. Okay, let me run it once. Okay, it's giving wrong answer. It's giving wrong answer. Okay, maybe um, OP. I have to initialize the OP and CL every time. I think that's why I'm getting this thing. I'm only getting this. Yeah, let me check. Okay, okay. Sorry. Maybe I have to think more. Okay, one thing I can do. One thing I can do. Okay, one thing I can do that. What I'll do. I will op plus plus. Okay, op, right. Then, yeah, also you can give like this and cl. uh, I don't need this. No, it will generate all the strings. Okay, okay. Uh, no, this thing will not happen. Okay, let me do one thing. I think maybe that's the problem. Okay, I can undo this. Uh, yeah. Now what I'll do that it's actually executing only one condition. So it will just okay, let me check that. Yep, yep, yeah, yeah, yeah. I got it correctly. Now it will. Mm, understood. Yeah. Okay. Maybe we are using recursion. That's why the time complexity, the runtime is looking very high. Okay. But if we can solve this problem with iterative way, then it may be faster. Okay. So this is the solution, I think. Okay. If let me check the solution. Okay. Uh, okay. Okay. Yeah. Yeah. They also wrote the same thing. The namings are a bit different, but it's okay. It's okay. Now look, now it becomes 2 because we are not checking the string. We are only selecting the correct string. We are only getting the correct string. So we don't need to check every time like the previous solution. That's why it become a solution of 2 power n. Okay, because on some cases for each call there both two if condition will be executed. So that the two recursive call will be generated, right? So for them the worst case sample purpose, that's why it will become 2 power n. Yeah. So this is the state space tree. Okay. So I have also analyzed this. And you can see it also here. Okay. It actually looks very similar. Uh, I done it up to this for n is equal to 2. Okay, for n is equal to 3, you have to do this part portion. Okay, so it depends on n. Okay, if I check it for like okay, let me check. If I check it for 9, let me check 2 power 9. The time complexity will be 2 power 9. Okay, okay. Okay, okay. Leetcode doesn't give the permission to.
give test cases on your without without maintaining the constant. Okay, you have to maintain the constant when you're giving any custom test case. Yeah. So that's my solution, guys. And hope you were with me, and also you can also do this on your own. Okay, I couldn't solve it, but yeah, it is my learning phase. It's a learning journey. It's a journey of learning. So, uh, so it's okay. It's okay. I learned that how to implement backtracking. Like when we are backtracking actually we are backtracking here. This portion. This portion is actually backtracking because we have already seen that if a string is meant to be a valid string, valid parenthesis, okay, then it must be start with opening bracket. So that's why to uh, to implement that logic, these two if functions were there. This opening bracket is should be less than n, and the closing bracket should be less than op. Okay. So this logic I have to find when I will sit for assessments or something. Okay. So yeah, that is the state-based tree. You can also refer from this. You can stop it here and see the state-based tree how the recursive calls are generated. Okay, this is the algorithm. Okay. Also, I have also executed the the old solution, which was time complexity of big O of 2 power n square. Okay, this is the state-based tree of recursive calls. Okay, so you can see. Okay, I don't know how much you understand, but yeah, I have tried my best. Uh, okay, so I don't have any kind of tool to show you better. Okay, I just you can also do it on your own machine, or you can take a notebook and try it on your own. Yeah, and this is the optimal solution. Okay, okay, I can close it. I can close it here. Okay, and if you feel that you are getting help with this journey, okay, with me, and you can also push yourself so that you can also be enthusiast with coding. Coding is fun, I feel, and yeah, if you like this video, please share, subscribe, and also you can comment so that I can understand. You can give me your feedback in the comment section. Okay, so yeah, that's all for today. See you tomorrow. Okay, I'm stopping you. Bye.